Baldwin Hills Dam, December 14, 1963. A worker at the dam notices an excessive amount of water seeping into the reservoir under-drain system. Suspecting trouble, he immediately notifies the operating systems engineer. The engineer determines there is a serious problem and directs attempts to correct the situation. As the problem worsens, the area downstream from the dam is evacuated. Despite all efforts, the dam fails. Although 5 people are killed and the area below the dam is severely damaged, thousands of lives are saved because the worker noticed something unusual and took action. As someone who may be at the dam regularly, you're in a good position to spot dam safety deficiencies at an early stage. Dam safety deficiencies may be readily apparent, but are more often quite subtle. By definition, they are problems that could lead to failure of the dam. Although you're not responsible for performing formal inspections, you do have an excellent opportunity to observe developing adverse conditions. Therefore, you should be alert for potential deficiencies that may endanger the dam. Report your concerns to the facility engineer, dam safety inspection personnel, the owner, or other appropriate authorities. Also, make notes of the conditions you find. Include such details as location, size, amount, and other factors that will help describe a potential problem and its severity. This video will help you identify visual deficiencies found on the crest and slopes of embankment dams. The crest, faces, and galleries of concrete dams, spillways and outlet works, mechanical equipment such as gates and valves, the abutments and reservoir rim, and the area downstream from the dam. Let's begin with deficiencies that may be found on the crest and slopes of an embankment dam. Things to look for on an embankment dam include new or unexplained increases in seepage, cloudy seepage, misalignment, cracks, slides, settlement, erosion damage, excessive or deep-rooted vegetation, animal burrowing, and damage to instrumentation. One of the most serious conditions is increasing or cloudy seepage. Seepage is a problem when it erodes embankment or foundation materials. Increasing or cloudy seepage is an indication that this is happening. During this process, known as piping, embankment or foundation material is carried away at the seepage exit point, forming a pipe. The pipe can enlarge and lengthen rapidly and lead to failure of the dam. Watch for seepage that appears for the first time, increases suddenly, or is cloudy. Areas of lush or water-loving vegetation can also be signs of seepage. Seepage is influenced by the level of the reservoir, so make a note of the reservoir level at the time of your observation. Another deficiency, misalignment, can be an indication of structural movement. To spot misalignment on a straight axis dam, sight along a crest linearity, such as pavement stripes, guardrails, or posts. Structural movement of the crest will often be reflected in these features. Cracking is another deficiency to be alert for, especially cracks that are new or enlarging. 3 types of cracks are found at embankment dams: desiccation, transverse, and longitudinal. These different crack types all have meaning with regard to the performance of the structure. Therefore, it's important to be able to describe any crack you observe by type if you can. Desiccation or shrinkage cracking is usually shallow and develops in a random or honeycomb pattern. Transverse cracks run across the crest, that is, perpendicular to the length of the dam. Longitudinal cracks run parallel to the length of the dam. If you see new cracks or cracks that have enlarged or lengthened, make a note of the location, dimensions, and type or orientation of the cracks. All cracks can lead to erosion gullies that may become severe over time. But more importantly, Transverse and longitudinal cracks can be an indication of serious structural problems within the dam. Cracking on the crest or slopes may indicate the beginning of a slide. Or by allowing rainfall to penetrate the embankment, cracking can actually cause a slide to occur. A slide is characterized by a steep backslope called a scarp, and if the slide has moved sufficiently, a bulge at the bottom or toe of the slide. Settlement is another embankment dam deficiency. If there has been widespread settlement involving the crest, a dam will have a swayback appearance. This almost certainly means a loss of the dam's freeboard, making it susceptible to overtopping during major floods. Localized settlements are known as depressions. Depressions have gently sloping, bowl-shaped sides and are usually not serious. A more serious type of settlement, a sinkhole, is characterized by steep sides where the soil has sheared as it settled. Sinkholes are serious because they indicate the removal of underlying material, possibly due to piping. If you find a sinkhole, contact an engineer immediately. Another deficiency to note is erosion damage. The slopes and crest are commonly protected by riprap or by grass. On grass-covered surfaces, look for bald spots or places where the grass is sparse. These areas are susceptible to erosion. Keep in mind that while shallow-rooted vegetation offers erosion protection, too much vegetation obscures the surface of the dam and hides potentially serious deficiencies. And deep-rooted vegetation can provide pathways for seepage. Animal burrows can also provide pathways for seepage. Heavy infestation on small embankments is of real concern. Riprap is often used to protect the upstream slope from wave erosion. But if the riprap is not properly sized, displacement of the riprap and beaching of the upstream slope is likely to occur. Finally, be alert for and report damage to instrumentation, such as survey markers, piezometer or inclinometer casings, and weirs and flumes. Now let's look at deficiencies that may be found on the crest and faces and in the galleries of a concrete dam. Most dams have concrete structures associated with them. Often the spillway and outlet works are concrete. The deficiencies we'll talk about can appear on any concrete structure, so you need to be familiar with them. At a concrete dam or concrete appurtenant structure, look for cracks, displacement, deterioration of the concrete, and leakage. Some cracks are serious, others are not. You should report any crack that has recently appeared, has enlarged in length or width, or exhibits displacement. Displacement can also occur at concrete joints. There are two types of displacement: misalignment, which occurs when the entire structure or feature moves, and differential movement, which occurs when one part of a structure moves in relation to an adjacent part. Sometimes displacement at a dam that has a straight axis can be detected by sighting along the crest and looking at the structure from several different perspectives. You can sight along parapet walls, crane rails, or handrails for indications of displacement. Another indication of displacement is cracks in the concrete around handrails and other embedded metalwork. Also look for concrete deterioration, including disintegration, spalling, slivers or slabs of concrete breaking away from the surface, pop-outs, small indentations left when portions of concrete break away from the surface, pitting, tiny cavities in the concrete, and scaling, flaking or peeling of the concrete or mortar. Now let's look at another problem that can occur at concrete dams: leakage. Leakage through the dam may appear as wetness, or water running from joints and cracks on the downstream face of the dam or into the galleries. Staining and vegetation are also signs of leakage. Another condition indicating leakage is efflorescence. Efflorescence is the formation of whitish calcium deposits on the surface of the concrete as leakage evaporates. Efflorescence may cause cracks or joints to widen, leading to faster deterioration and increased leakage. However, in some cases, the deposits may seal the crack against additional leakage. If leakage has increased or appears at a new location, note the amount of flow. Also, record the location of new leaks. Locating deficiencies on the upstream face may be difficult. You are usually limited to looking for deficiencies above the waterline. Make it a point to visually scan the upstream face from the crest, the abutments, or if you have the chance, from a boat. When or if the reservoir is low, use the opportunity to look for problems on the upstream face that are normally underwater. Check for cracks, concrete deterioration, and displacement. Try to identify cracks that may be the entry points for any leakage observed in the galleries or on the downstream face. Also keep in mind that the level of the reservoir influences such factors as leakage rates and crack openings. So note the level of the reservoir at the time of your observations. Finally, whenever you're in the interior galleries of a concrete dam, check the foundation drains. These drains help relieve uplift pressure beneath the dam. Sometimes drains become clogged with chemical deposits. Clogging reduces flow and causes dangerous uplift pressures that potentially can affect the stability of the dam. Note the location of any drains you suspect may be clogged. Now let's turn our attention to problems that may be encountered at spillways and outlet works. Spillways and outlet works regulate releases of water impounded by a dam, either normal flow or floodwater resulting from heavy rains or melting snow. Spillways and outlet works are susceptible to deficiencies such as obstructions, displacement, material deterioration, and seepage and poor drainage. Let's take a look at these deficiencies. Obstructions such as bushes or trees, material from slides or rock falls, and other debris can block the flow paths on spillways and outlet works. On the side slopes of earth or rock-lined channels, look for signs of instability or slides that are blocking or could block the channel. Check earth-lined channels for erosion damage or bare spots that could lead to erosion. Also check for undercutting of the slopes and possible slides. Erosion can also occur to riprap-lined channels if deterioration or displacement occurs to the riprap due to wave action. Concrete spillways and outlet works can exhibit the same material deficiencies found in the body of a concrete dam, including cracking, spalling, pop-outs, pitting, and scaling. In addition, concrete as well as metal surfaces subjected to high velocity flows are susceptible to cavitation and erosion. Cavitation is a destructive process caused by the collapse of vapor cavities introduced into the flow by offsets in the flow path. Cavitation may appear as pitting at first, but then becomes deeper and more extensive with time. Erosion is the wearing away of a flow surface caused by rock or soil particles suspended in the flow, being swept over the surface at a high velocity. Like cavitation, erosion damage is progressive and can be very destructive. Another deficiency to look for is structural movement at concrete joints in walls and floors. Structural movement may occur as differential movement, separation at joints and cracks, or compression evidenced by crushed concrete or extruded joint filler. Look behind chute or channel walls for depressions or sinkholes, and look to see if weep holes and drains have become clogged. Check exposed trash racks for debris that may restrict flows. A decrease in discharges at the same reservoir level may indicate blockage of the intake. Also check to see that trash booms are afloat and have not separated. Metal conduits are susceptible to corrosion, rust, scaling, flaking, and pitting, especially if the paint or protective coating is damaged. And as mentioned earlier, cavitation and erosion damage may occur. Be alert for seepage that may be flowing into a conduit through joints or cracks. Continued flow from a conduit after a non-leaking upstream gate has been closed is evidence of seepage into the conduit. Check for any soil particles that may have been piped into the conduit. If you see seepage exiting from around a conduit at the downstream end, it should be considered a serious situation. Alert an engineer immediately. Mechanical equipment is also important to the safety of a dam. Gates and valves control the flow of water. Scheduled operation and testing of gates and valves provide the best opportunity to look for deficiencies. Always make sure that you follow procedures that ensure upstream gates or valves won't be opened accidentally while you're in a fluid way. Problems to be alert for on gates and valves include surface damage, corrosion and cavitation, damage to gate and valve housings, rough operation, and damage to the gate or valve operator. Surface damage may appear as cracks, broken welds, missing, broken, or loose parts, and the loss of protective coatings that could lead to corrosion and rusting of the metal. One type of corrosion, called galvanic corrosion, occurs when two dissimilar metals that are touching each other come into contact with an electrolyte, such as water. As with other features subject to high-velocity water flows, gates and valves can suffer from cavitation. Also check the housing or frame for damage, bent members, and misalignment, and examine seals for signs of deterioration. Look at the seal plates for evidence of binding, such as scrapes and gouges. Operators should be checked for missing, broken, or loose parts. Look for corrosion damage at hoisting connections and damaged stems or stem guides. Check hydraulic fluid levels and look for signs of oil leakage, especially around the gate stem. Test operation of gates and valves is another way to spot trouble. As the gate or valve is operated, listen for unusual noises. If the motors sound like they're straining against the load, or if you hear unusually loud humming or squealing, problems may exist. Touch the motor. If it's too hot to touch, that may indicate overloading. If possible, look to see that the gate or valve moves evenly. Jerky or rough operation, excessive vibration, abnormal noises, and binding are all signs of trouble. Also, check the mechanical equipment that is used for emergencies. Auxiliary power systems must be in good repair and should be test-operated periodically at intervals specified in the standing operating procedures. Deficiencies that jeopardize the safety of a dam are not always found on the dam itself. Problems can also occur on the abutments, around the reservoir rim, and in the area downstream from the toe of the dam. Many of the same deficiencies found on an embankment dam may also be found on the abutments and reservoir rim. On the downstream side of the abutments, look for signs of seepage, such as wet spots and lush vegetation. Stains on rock surfaces may also indicate seepage or that solutioning of the rock is occurring. Note the location of any seepage areas. Check for slides or signs of slides, such as cracks, scarps, bulges, and leaning or pistol-handled trees. Slide material or other debris can block intake or outlet works, or damage appurtenant structures. Also look for depressions and sinkholes, animal burrows, and deep-rooted vegetation close to the dam that could provide pathways for seepage. It's unlikely you will ever see a whirlpool in the reservoir. However, whirlpools do indicate a heavy concentrated flow from the reservoir and are a serious condition, especially if they are near the dam. Report any whirlpools immediately. Now let's turn our attention to problems that may be found in the downstream area. These include increasing or cloudy seepage, sand boils and sinkholes, unexplained increases or decreases in controlled seepage from tow drains or relief wells, and problems with the devices that measure seepage flow. Seepage downstream from the toe becomes a serious problem when erosion of foundation materials or piping occurs. Cloudy seepage indicates piping, so check the clarity of the seepage. Sand boils result from excessive seepage pressure. Their presence may also indicate piping, particularly if a cone of material forms around the boil. Report sand boils immediately. Lush or water-loving vegetation downstream from the toe may be another indication of seepage. Check areas of lush vegetation for seepage and note their locations. Also, flow from toe drains and relief wells provides information on seepage conditions. Check the amount of flow to see if it is different than it had been previously for similar reservoir levels. Weirs and flumes are used to measure the flow of water. Check to see that the staff gauges are legible and have not been moved or damaged, that water is not bypassing the device, and that debris is not blocking the flow of water. If you find any of these problems, correct them. A buildup of silt in a weir box may mean that piping is occurring. Also, note changes in the amount of flow and look for cloudy water. Report cloudy water to an engineer or other appropriate person. Check piezometers or inclinometers for obvious signs of damage, such as bent riser casings. And look for missing caps or locks. This presentation covered deficiencies you may encounter as you go about your duties at a dam. Take time to be observant about the condition of all features of the dam. Your observations are important. Remember, be alert to anything unusual and always look for any changes that may have occurred. Report any concerns to a facility engineer or the appropriate authorities. Your efforts will help ensure the safety of the dam.